Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Stop Container Attacks Using MITRE ATT&CK for Containers, brought to you by NewVector. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to view it on demand. We will be sending out a link to access the webinar, or you can visit devops.com/webinars or containerjournal.com/webinars, and it will be available for you there. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab, and we also encourage discussion by using the chat tab. So let us know your thoughts or just say a quick hello. There is a handout that has been made available for you to download, so check that out in the handout section. Finally, stick around until the end because we are doing a drawing for four $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Glen Kosaka, VP of Product Management, NewVector. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
All right, thank you very much, and thanks everyone for joining me today. Very excited to talk about this topic. It's a new topic for us, and that is how to protect your containers and Kubernetes deployments by mapping the certain attack techniques against NewVector. And these attack techniques are presented and summarized in what's called the MITRE ATT&CK framework. So I'll cover a little bit of the context of containers, talk about what MITRE is, talk about their new container attack framework, and how NewVector can help you protect against those types of attacks. And of course, as always, if you have any questions as we go along, please put them in the Q&A, and I will hopefully be able to get to them at the end. All right. So big picture, of course, all of you are going down your cloud journey in various stages of containerizing the applications and microservices. And there's tremendous benefits that you and your company can get from the movement to containers and microservices. You can do huge deployments very quickly, very easily, by scaling up and down very quickly using public cloud resources that are available 24/7. One of the biggest benefits is more frequent and faster software releases. So I know some companies are releasing hundreds of new updates to their application services every day. But if you were previously in a waterfall method and releasing once every 3 months or once every 6 months, even being able to do a new release every day is a tremendous step forward. So, and you know, of course, that means that you can be more competitive, you can get more features out, you can fix bugs, all of those good things. In order to do that, you need to adopt in some way highly automated operations. And the ability to do that will give you the ability to automate your pipeline. And of course, what's most critical is making sure that automation in your pipeline is secured. And then finally, by better matching the resources that you're spinning up and scaling down to the actual demands that your customers have and your applications need, you're able to reduce the costs of your deployments in many cases. So let's talk about, in general, at a high level, what the container attack surface is. Now, remember, we're talking about not just a production environment where containers and Kubernetes are running. We're talking about the entire pipeline from when the developers build their apps, perhaps using some open source components, building those into a container, and then moving it down the phase, putting it in registries, test staging, all the way into production. At any point in that pipeline and in production, critical vulnerabilities can either be introduced into the pipeline, or be announced or disclosed even once you're running those containers in production. One of the critical things with this automation in the pipeline that I talked about is security cannot break your pipeline, or more accurately, can't slow it down. Gone are the days where you have to make a request to the network team that you have a new app. It requires a new port or a new protocol to be allowed through your firewall, and that will take 2 days. Any type of manual security configuration is just not going to scale in this type of new cloud native environment. We're working with a lot of new tools, and you are. Some of them have pretty challenging learning curves. Even Kubernetes, which is well documented and getting pretty mature, it requires a pretty steep learning curve. And because of that, there is a great chance of misconfiguration, whether it's leaving your console open and getting a crypto mining attack like we saw from Tesla a couple years ago, or not configuring your RBACs properly to allow insider attacks, or registries where unauthorized people can introduce tainted images into your registry. Misconfiguration is a continual potential issue. We have a new attack surface. Specifically, any of the tools you're using to deploy and manage your containers can also be attacked. Kubernetes itself, or the runtime, whether it's Cryo, Containerd, or Docker, the runtime you're using presents an attack surface. In fact, we had a man-in-the-middle attack vulnerability disclosed last year in Kubernetes where somebody could hijack connections to external IP addresses. And it's a very easy to implement man-in-the-middle attack. It's something that we can demo and show very easily. And things like that need to be able to be detected as well as prevented. And then finally, in production, the containers can be hacked or attacked just like any other non-containerized environment. They are, after all, applications that are running, and applications can be attacked. Maybe privilege escalations to get to the host. The hosts can be attacked on which the containers are running. So just because you have reduced the footprint of your containers does not mean they're immune to attacks. So containers and applications need to be monitored and protected, just as they have been all this time. So to make life a little bit easier for you, security professionals, the MITRE organization has prepared a attack matrix for containers. This was released earlier this year, so it's great to see the attack matrix now covering some of these new cloud native technologies. If you're not familiar with the MITRE attack frameworks, this organization collects through a community effort various types of techniques that attackers will use and sub-techniques to attack various aspects of the topic. And in this case, it's containers. So, and then they categorize those into these categories that are appropriate. So in this case, how do they get access, initial access? How do they execute persistence, privilege escalation, all the way down to the impact of these attacks, whether it's a denial of service or a resource hijacking. So throughout the presentation, there's links in the presentation that you can use to follow along and try these out on your own. So I'm going to show you how the MITRE attack for containers works. So to do that, I'm going to switch to my browser. And so this is the URL that was at the bottom of that slide. And if you bring it up, you can see the container matrix. The way this is structured is, as we saw, initial access. So there are 3 techniques for initial access. One of them is to exploit public-facing applications. Surprise, right? So what we're able to do is we're able to click on that particular technique, and we see a detailed description of what this means, especially if this is exposed to the cloud through your cluster. You can see it mentions OWASP top 10 as well. And there are so many examples for exploiting public applications. Now, not all of the techniques have this many example exploits, but of course, there are many for applications. So any of these are possible to exploit public applications. You would go through and evaluate these to determine which of these might apply to your specific applications. For example, SQL injection. If you're not using a SQL database, then perhaps you don't need to be concerned about this. And then the framework goes into mitigations. What things can you do to prevent this particular attack technique? So application sandboxing and isolation, of course, WAFs, segmentation. You'll see network segmentation mentioned in many of these techniques, because if you can't get into the application or get out of the container, then it will prevent an exploit, a successful exploit. You also see references in many cases to vulnerability scanning, because many of these procedures, they call them, but many of these exploits are exploiting specific CVEs that exist in certain applications. So, of course, it's critical to have a good vulnerability scanning capability. And then the attack framework also goes into how do you detect these? Monitor the network traffic, monitor your application logs. Of course, if you have a WAF in place, you can monitor the WAF alerts as well. So that is a quick example of how to use the MITRE ATT&CK framework for containers. And each of these, now, one thing I will say is that, for containers, this is a fairly short list. We'll see later when we take a look at some of the other ones, there are probably 50 or 60 techniques and sub-techniques. So the important thing is for you to prioritize and look at the ones that are going to be most damaging to your particular infrastructure and application, and then to focus on making sure you've got mitigations or preventions in place for those. So as we go through this, I'm going to be highlighting the ones that we think are most critical. Those would be things where the attack is really becoming critical. Privilege escalations are those. If they're actually connecting to a command and control server, or exfiltration, stealing sensitive data, that is you're at the last point at which you can try to detect that before it's very damaging. So of course, those would be the most important to focus on. All right, so let me switch back to my slides here. So what we've done at NewVector is we've mapped all of the NewVector protections against what we just saw, all of these techniques. And you can actually play with those in this link right here and load them into an interactive tool, which is the Attack Navigator tool. So what I'm going to do is I'm going to grab that URL. And I think I've got to go back to the screen and go to, so this is the link for the Attack Navigator that's in the bar now, or in the PowerPoint. Now it says here you can load from URL. So the next URL down was the one that I included in the PowerPoint. And let me just delete this one, make sure I'm using the right one. And you can see the NewVector mappings to all of these container attack techniques. So for example, if you mouse over exploit public facing application, you will see NewVector's comments of how you can mitigate these. Network segmentation, ingress and egress control is provided, vulnerability scanning, we talked about that. And then admission controls to make sure that privileged containers are not allowed. OWASP top 10 WAF type of protection rules to protect your public-facing application. So as you go through here, you'll see all the green areas are areas where NewVector is providing complete coverage and protection for that particular technique. The yellow marked techniques are those where we can provide partial protection for those. And the white ones, typically here you're seeing default accounts and local accounts are not going to be provided as a security protection by NewVector. And you could see as you go through these that those tend to be things like here you can see default accounts or local accounts, making sure that you're properly managing your local accounts. Let's view the technique and obtain and abuse credentials. And then they can do a privilege escalation. So this is where it's critical to lock down your accounts, and you might use mitigation such as password policies or account management. So you could see that that's related to other tools that you might use to do this, or processes that you might do to mitigate that. But you can also see that one of the things that could happen is privilege escalation or defense evasion if an attacker was able to get in there. And you could see here, okay, once they try to do a privilege escalation, in this case, NewVector would have you covered on that so that we can detect either host or container privilege escalations. So that's a quick example of how the interactive attack navigator works. All right, so let's go back to the tool oh, yes. And so for those of you who are not familiar with NewVector, I thought I should take a little pause at this point and just give you a high-level overview of what NewVector is. So NewVector is an end-to-end full lifecycle container security platform. So we're going to be able to protect your pipeline and production deployments from the very early stage, in this case, the build phase, where the developer can be building their container images. We can scan those images for vulnerabilities, compliance violations, secrets, deployment issues in their YAML files. A number of things can happen immediately, and that can be forced back to the developer to remediate those before they're even allowed down into the pipeline to be put into your production or staging registry. And then the vulnerability and compliance management continues into registry scanning, continuous monitoring of that, running of CIS benchmarks and custom audits for your containers and your hosts, PCI, GDPR, other types of compliance reports. And then during runtime in production, scanning containers, hosts, and platforms continuously for vulnerabilities and compliance violations, misconfigurations, and other things. So we make it very easy for you to report on these and then to highlight which ones are the most critical things to focus on for your remediation. The second part of the product line, a lot of times I like to say it's the most critical because ultimately hackers are going to try to get in and steal data in production. So this is the runtime protection. And it really starts with admission controls that prevent unauthorized or non-compliant deployments into your production environment. And then for runtime protections, it's a combination of a layer 7 container firewall, as well as container workload security, where we monitor the process and file activity of every container that is running. So NewVector employs what's called a zero trust model, where we will use behavioral learning. You can see here in the test stage, you can use behavioral learning. We'll learn all the network behavior, process and file behavior. We will then prepare or create a set of sample rules that we think are needed to lock down that application. You can then export those as a YAML file, as security policy, as code, modify them, update them, test them again, check them into your Git repo, and then push those as kube control apply of that YAML file into your production environment. And all of the protections will be in place before you even attempt to deploy your application. So this is really enabling that automation that I talked about. The focus of today's presentation is more in the MITRE ATT&CK framework and not necessarily NewVector, so we can go deeper in future presentations, or you can contact us for more. Although I will show briefly some of the NewVector console today. All right, so back to the attack for containers. Now, I did mention that we would highlight what we think are some of the most critical things for you to focus on. Make sure you take care of these, and then evaluate the other ones that we saw in the matrix. So first of all, the deploy container a technique. This is where you can use admission controls to make sure that only authorized and non-vulnerable compliant images are allowed to even run in your production environment. Exploit public-facing applications. So we actually went through this example and we looked at the NewVector protections for ingress and egress control, segmentation, OWASP and WAF type of protections using the NewVector deep packet inspection engine. So this is where we can inspect all of the network traffic on a packet-by-packet basis going between pods or ingress and egress out of the cluster. For privilege escalations, it's actually a multifaceted approach or a multi-vector approach. We will detect privilege escalations on the host as well as container breakouts. And then if they are successful in privilege escalation, the next thing they will probably try to do is break out of the container, either move to another pod, scan the network, move to the host, and try to get out of the host. So that's where our zero trust model is going to be monitoring the network connections, all of the processes in the container, as well as the file activity to make sure that privilege escalation is not trying to expand its blast radius. Network service scanning is another one. It's obviously a common technique for figuring out what's the next point in my kill chain of attack. Where can I go? How can I find an application that's vulnerable now? How can I find a source of data that I can steal? So in order to prevent network scanning, network segmentation, don't allow inappropriate network connections. Only allow the ones that have been in your zero trust model. We also will have built-in detection for known malicious processes, Nmap being the most obvious one as a port scanning process. So we can alert you, we can block those, and we will detect that as a combination of both the network process starting as well as the network connection itself being attempted. Denial of service and resource hijacking. Again, this is a combination of built-in DDoS protection within the network inspection that NewVector is implementing, as well as resource hijacking can be prevented by all of the zero trust protections. Any attempt to hijack a resource, in this case, it might be more related to unauthorized file access patterns that we can detect, or it may be a process that is starting up that is used to hijack those resources. So that's a good example of what you can focus on in this as you work through the MITRE ATT&CK matrix for containers. Now, one of the things that we like to summarize a lot of this on is called virtual patching. And it's really around the concept that with this zero trust model, we're going to learn and allow list all of the network, process, and file activity that a container takes and is allowed. And any unauthorized network connections, processes, or file activity is going to be detected. And you can choose which deployments you want to just alert you on and which ones you actually want to block any of that activity. By being able to do that, we are able to prevent vulnerability exploits from being attempted or successful. More importantly, zero-day attacks. Those are attacks where the vulnerability has not been discovered or disclosed, or it's a novel type or way of attacking an application or infrastructure. Embedded malware, somehow if malware or backdoors were able to be injected into your image or into your container or host, we're going to be able to detect that activity, as well as other types of attacks. Once they try to expand the blast radius of their attack, we're going to be able to detect and prevent that. So let's say you've gone through all of that, you've focused on those most important techniques in the MITRE attack matrix for containers. Are your containers now secured? Are you done with your security project for the container infrastructure? Well, the answer is definitely no. You are far from done. If we look at the description of the attack matrix for containers, it's covering techniques against container technologies and for the container platform. So this container attack matrix is more focused on the technologies used to manage containers, such as your orchestrator. But as you all know, what about the network that the container is running or using? What about attacks that are using the container network? What about attacks against the actual host where your orchestrator is running on? Or, all containers or most containers are typically running some type of OS distribution. What about attacks against that? So we need to look at a couple other matrices, that for network as well as that for Linux. So the MITRE framework exists also for network and Linux attacks. The reason this is so critical is that, number one, network attacks, this is really the most critical, we think, attack matrix that you need to pay attention to. And the reason is that the attacker will use the network to get into the container to potentially try to exploit a vulnerability or to initiate a zero-day attack. They will use the network to expand the blast radius of the attack to look for or probe for other applications or pods. And then they will use the network to egress, either to a command and control server or to actually steal data. And so, number one, we need to look and prevent network attacks. And then number two, against attacks against the host or container OS can result in privilege escalations, escapes, attack on the orchestrator system. So if you can get to the host, you can kill all the Kubernetes API servers or kubelets or other system resources that are running on the host. Also, it can be used to expand the attack. So here I've got a couple links to the attack matrices for network as well as Linux. So we can do the same thing. We can map the NewVector protections against the MITRE attack framework for network. And so for that, I'm going to grab the URL for the NewVector mapping against that and show you how that's done. So I'm going to switch to my screen here, go back to my attack navigator, open a new tab, put in that URL. All right, so now you can see the NewVector protections against the MITRE ATT&CK framework for network. And you can see it's similar to the container protection, but there are different categories and different techniques. And if we look to the right side here, you got discovery and impact as the rightmost ones. Here, discovery, you've got discovery, then you've got collection, command and control, and exfiltration. So you have categories of network techniques that, in our opinion, is much more serious, much more damaging. If they're collecting information using the network, if they're connecting to command and control servers, services using non-application layer protocols, or if they're trying to exfiltrate data using tunneling or other techniques, these are things that you definitely need to focus on and prevent. But you can see here, NewVector has quite extensive coverage for the attack net framework for network. Okay, so let's go back to the slides. And as I mentioned, we'll highlight certain things about this matrix that we think you should really pay attention to and make sure that you have preventions in place. So these are the categories of discovery, collection, command and control, and exfiltration. So with discovery, you can use admission controls, man-in-the-middle attack prevention, scan detection, as I talked about, Nmap scan detection, to make sure that discovery activities are not occurring. In the man-in-the-middle prevention, that also applies not just to your application containers, but also to the vulnerability of the Kube API server that we talked about. NewVector can detect those man-in-the-middle type of attacks. For collection, this is a lot of times people are looking for secrets or tokens or things that they can use in the next step of their kill chain. So making sure that you're running scanning to detect if secrets are in any images, making sure you're running the CIS benchmark audits to make sure that all configurations are properly set and RBACs are set so that somebody can't get in there and steal some type of sensitive data that can be used in the next layer of attack. If they're able to do that, of course, you've got the network DLP actually looking for those secrets in the network traffic that NewVector provides, and network segmentation to prevent exploit of those. Now for command and control, I highlighted the techniques here. Non-application protocol can be used to connect to the command and control server, proxying or traffic signaling. So these preventions can be used here with NewVector to prevent connections to command and control. Now, first of all, there's really great egress controls. You can see I mentioned that down here, but there's great egress controls in NewVector. So that, if you've got egress controls and a pod is not even allowed to exit the cluster, all of these, none of these techniques can be used. But if they're trying to use, a lot of times you do have to allow DNS to get out of the cluster, maybe ICMP, and tunneling can be used to connect to command and control. So deep packet inspection, DPI, is something, network DPI is something that is a technique that we implement so that we can see into the network payload. Application segmentation, making sure the proper application protocols are used. And then we also look for suspicious process, known suspicious processes like reverse shells that are often used to connect to command and control services. So it's really a combination of the network and the process activity that we're looking at for this technique. Exfiltration, I mentioned egress controls. we have very powerful DLP packet payload inspection. So if there's any sensitive data trying to be egressed out of the cluster, we can detect and block that. And then, as I mentioned, DNS and ICMP tunneling can be used to take sensitive data out of your enterprise. I think I forgot on the previous NewVector description to do this NewVector demo. So why don't I give you a quick tour of the NewVector console. So this is NewVector. Our product is a container itself, and we're deployed in multiple Kubernetes clusters, so we can manage multiple clusters across the cloud. We will show you a dashboard which summarizes how exploitable your infrastructure is based upon the NewVector protections that are in place or not in place, and the vulnerabilities that exist. We will also show you all the ingress and egress exposures, the connections that are going from which pods to external sources, and whether those were allowed or blocked. We can even show you all of your application protocols in your infrastructure and the volume of activity being used by application protocol. And this is all data that we're getting from our unique packet filtering technology. The visibility of all of the nodes in your cluster, all of the pods running, all of the network connections, and which protocols are being used is shown in this summary. So you could see here there's legitimate application traffic that we're seeing to this WordPress application, but we can also see there's suspicious connections, DDoS, as well as a old version of SSL, which is exploitable, that's being used in some of the connections that we're detecting. So this is where, from a visual standpoint, you can see what's going on. You can filter very easily on namespace or pods if you have a very complex environment. And you can do specific actions such as see all of the network sessions that are active, initiate PCAP packet capture sessions, change the protection mode, and even quarantine this container if it's looking suspicious. Under assets, this is where we're going to scan the Kubernetes version. Oh, you could see here this version of Kubernetes 120.9 has a high vulnerability. So that is something you might want to take a look at. Although when you're running on a public cloud, the best option is just to upgrade your Kubernetes to a more recent version. We'll also scan all the hosts for vulnerabilities. So depending on what distribution you're running, we will run the vulnerability scans and also all of the CIS benchmarks. This is a view of your containers where you can see vulnerability and compliance information on all your containers, as well as stats about your containers. And this is where you can do the registry scanning that we talked about for your images. We can see any of the scans. We can see all of the different layers of the image and vulnerabilities that exist in each layer. We can also see image-related compliance checks. For example, if there's a secret embedded in the image, we will let you know that it's there. And you can summarize your module inventory and see which ones of your modules have fixable versus non-fixable vulnerabilities. So this is a great start to locking down your environment, but ultimately it's the runtime protection under policy that I mentioned are going to really be able to prevent a lot of these techniques. Admission control, this is where you can create rules that will allow or block deployments. We provide a default one for PSP best practices, but you can also do things, for example, I don't allow any severities, so greater than or equal to 1, and if it's more than 7 days old, the developer has had to, is going to be forced to fix that. So we'll enable that admission control rule. And now any deployments that are attempted that have any critical vulnerabilities where there's a fix available that are more than 7 days old, we're in a protect mode, so it's going to be blocked. And that deployment is not going to be allowed. So there's many different criteria you can use for admission control. Environment variable, you can use labels to control admissions, privileged and root, namespaces, a number of those. This is a great tool for you to block, or as the gatekeeper to your production environment. And then finally, when you're in the production environment, you can use the network rules to review all of the network connections that are allowed in your containers. So if I go to my Node.js deployment with 3 pods, I can see that these 3 network rules, these are layer 7 firewall rules with application protocols that are allowed. These are the only network connections allowed. You can see here, no egress connections are allowed from these pods. So any attempt to do exfiltration is going to be detected and blocked by NewVector. Similarly, there are a number of process rules, and you can also have file access rules to lock down certain files. And so if Nmap tries to start up within this pod and we're in a protect mode, NewVector will block that network scan from happening. Now, the DLP sensors is an additional capability of deep packet inspection where you can set up inspection on the network payload. You can look for things such as credit cards, social security numbers, specific email addresses, or WAF type protections. So these are examples of WAF type protections: cross-site request forgery, file uploads, scripting, even API service protection. We have built in SQL injection attack detection, so you don't need to add that here. And the way we do SQL attack injection detection is between a pod to the SQL server. So it's a much more accurate way of detecting a SQL injection. We're not looking at the web front end, which could be prone to false positives if you put a bunch of rules in there. We're actually looking at the SQL connection. So that's a quick tour of what NewVector is. Let's see where we are. Okay, let's look at the Linux mapping. Linux, as you all know, is huge, and there could be so many things running in Linux, so many distributions, so many possible attack vectors that this matrix is actually very huge. But not to worry. We can help you prioritize what's important. So again, if I go through and load in the NewVector protections for Linux, you will see that the areas that we focus on are, the most damaging areas: lateral movement, collection, command and control, and exfiltration. Obviously privilege escalation, and a few other ones of executing unauthorized scripts. Now, the reason this is so big is that you can pretty much have anything running on Linux, and so there are so many different attack vectors on Linux. Now, the good news is for your containers themselves, you can and should be using hardened versions of Linux distributions. You shouldn't include all of the packages and libraries that are going to allow all of SSH, for example, or scripts to run, or any of these things that you could see here. Your container should be hardened, and that in itself will eliminate a lot of these ones in white for your container. For your host, it may be a little more necessary to include more of these, and that's why we do recommend that you use other tools like SE Linux or other third-party tools just to do basic Linux host protection if you need to, because you have certain packages or libraries that you want to protect in your Linux deployment. So if we go back to the presentation, again, we focused on some of the most critical things, the most damaging things for your business, for your critical data, for your application health. Many of these are the same. So we've already gone through privilege escalations, collection, command and control, and exfiltration. One of the new ones in there that we would highlight is also lateral movement. This is where if the container or the host is exploited, then lateral movement is going to be one of the most common techniques that is used to expand the attack. And as I mentioned, we do recommend you supplement our host protections with traditional host security tools. NewVector does give you the capability for locking down all the process activity on the host. So we can learn all the processes that you are running on your host. You can declare those as well if you have known processes, and we can lock that down as well. We can block unauthorized processes from starting on the host itself, not just the container. So there is some level of host runtime protection that is provided by NewVector. And in addition to that, we will scan the host for vulnerabilities or run all of the CIS benchmarks, and you can have custom compliance checks that are run on the host as well. So you may have heard me talking about a kill chain or blast radius. So it makes sense to just reiterate that point. A typical damaging, successful attack is a series of events which are typically called a kill chain. And that kill chain will use a number of those techniques that we just saw to get in, to expand, to exploit, to probe for a secret or credential, to connect to command and control, and maybe even try to download a exploitable package, exploit it, and then ultimately steal data or damage your infrastructure. So there's a series of events, and we have an opportunity to detect that activity at many points in the kill chain. As I've mentioned, the network is the most critical part of the kill chain to make sure that you have visibility and protections in your container environment, because the attackers will use the network to get in, to expand, and to get out. So, all of these examples that we can see here are examples of real exploits where we or you could have detected these exploits from various points in the kill chain. So as you can tell, there's a lot of capabilities that NewVector provides in the full lifecycle container security product. But some of the areas that we'd like to highlight where you will not see this with any other container security platform is the unique workload visibility and production and the zero trust protection, especially focusing on the packet level, deep packet inspection, network segmentation, network visibility, the ability to run certain workloads in a inline firewall mode where we will block attempted exploits or data exfiltration, And we use that capability to also implement DLP, looking at the network payload. So that, being able to detect sensitive data is a critical aspect of PCI compliance, but also for other compliance regulations, GDPR and others. We wrap that up into a fully automatable solution. So all of the technology, it can be built into your pipeline, can be automatically deployed and configured. And I mentioned if you have this fully automated application pipeline, you can actually deploy the NewVector protections for your applications and keep them updated through the CRD, which is a custom resource definition, a YAML file, which you can manage as security policy as code, just like you manage all of your other code. So the ability to keep up with those rapid application deployments is something that we continuously focus on and give you the capabilities for. Now, so for those of you a little curious as to what is the technology under the covers, I'll end with a brief overview of the NewVector components and technology. This is a typical Kubernetes cluster. So we deploy our containers as a control plane, just like Kubernetes. One is active, so you only need one. This is really the brains. This is where all the rules are kept. Any alerts are integrated with your SIM here. Webhook alerts are sent out here. And you can manage NewVector there. The scanner is a fully scalable set of scanner pods. So if you have 100,000 images in your registry and you need to scan those in it might take a day, but you can scale this up to 50 scanner pods if you have that many hosts and resources. And the controllers will dole out scan jobs, or you can scale it back down to one when you don't need it. There's a web console, which is what we were taking a look at. The web UI is stateless, and it uses the REST API to get all information through the controller. So you don't really need this. You can control NewVector completely through the REST API. And the workhorse that's doing all the packet inspection, the on-host network inspection, blocking, process file, vulnerability scans locally is done by the enforcer. And this is a lightweight container that is deployed as a daemon set. So if you scale up your cluster to 20 nodes, Kubernetes will automatically put an enforcer there. It'll join the cluster, connect to the controller, get its policies, and your protection will be immediately turned on. All right, so that's a quick overview. I hope that you've enjoyed this webinar, and would love to take any questions. So we'll just power through those as quickly as we can.
Yes, we do have a few questions. We do have time for a few questions. If you do want to submit a question, just head on over to the Q&A tab. First question, how is NewVector priced?
Well, that's good. For the last slide, we were looking at those nodes. Typical pricing is how many hosts or worker nodes are you protecting in your production environment? And so there's an annual subscription for each based on the number of nodes in your cluster that's being protected.
Excellent. Next question, is NewVector FedRAMP compliant?
Well, NewVector is not a SaaS product. However, we enable many of our customers to become FedRAMP compliant because of our protections for their applications that are being used in a SaaS environment. All of that infrastructure that I showed you can run in an air-gapped environment, and most of our customers run NewVector in their own private cloud, whether it's in AWS or on-premise. NewVector does not require any external connections to any SaaS, so therefore, it's not relevant to us.
Understood. Next question, do you use IP tables?
Probably referring to the network packet filtering and protection functions. No, we do not. This is our own technology. We made an announcement at KubeCon that we've been recently granted 2 additional patents to add to our previous, I believe, 6 or 7. We have a lot of core technology around how we're able to inspect the network traffic and how we're actually enabled to be in line. We don't use network policy. We don't rely on it. We don't rely on tools like eBPF or IP tables. It's pure NewVector technology. One of our co-founders actually wrote all the deep packet inspection engine at Fortinet. This is a real layer 7 firewall you're seeing.
Okay. Next question. How do I load the NewVector protections? Can't get the URL to work.
I assume you mean in the attack Navigator. Let's see if I don't know if this, yeah. So I had certain problems. Maybe what you mean is here when you load these URLs in, by the way, you can download the file and upload a file. What I discovered after many frustrating times is you've then got to click this invisible tiny little blue button here in order for it to work. So hopefully that answers your question.
Okay, we have time for one more question. Does NewVector store the data collected? If yes, what is the backend data platform to store / process all those data all the data that NewVectors collect / detect?
Yeah, good question. No, we do not store, generally, we do not store all that event information. We do store some of that in memory. So when you see it in the console, we are showing you kind of live events as well as much as like 4,000 events for each type of event that we can hold in memory. NewVector is designed to work with your SIM. So a syslog or Prometheus exporter or other types of connections are supported. And all of those events then get sent up to your SIM system. You can also have certain ones sent like scan results for vulnerabilities. You can have them sent to other destinations. We can also send webhooks for specific types of events or scan results to a webhook endpoint. And then, of course, there's a REST API. A lot of our customers, when they get a notice of a scan event completed, they will use the REST API to just pull that scan result into their scan result repository.
Excellent. Well, we are nearing the top of the hour, but I just did want to remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand. The webinar will also be available on devops.com or containerjournal.com. Just look in the on-demand section and the webinars page, and it should be there. To announce our 4 Amazon gift card winners for today, our first winner is Sergey T. Congratulations. Our second winner is Felicity C. Our third winner is Michael B. And our final winner is Colleen F. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Glenn, thank you very much for taking the time to put this presentation together. The chat seemed to have really liked it. So
thank you. Thank you, everyone. Have a great day. And thanks for joining.
Of course. Yes, thank you to the audience for their time and engagement. This is Julio Godinez signing off until next time. Be well.